Welcome back to class. We are going to get started here with Chapter 13, States of Matter, page 384 to 409 in your textbook. And please refer back to your textbook if you need extra information or clarification, because everything I talk about in the lectures is always going to be found in the textbook. All right, so let's begin. Oh, here we go, here we go. Boom. All right. So when we talk about states of matter, it would be hard to get into a discussion about that without just talking about our planet Earth. And as you can see, as you look at this picture of the planet Earth, you will see that most of our Earth is covered with liquid water, and that would be the oceans. But liquid water is also found in rivers and streams and lakes. And then very cool thing about our planet is that you will also find water in the solid state, which is ice down at the South Pole or up at the North Pole, tops of mountains. And in our atmosphere, you'll find the third state of water, which is a gas. And a lot of times students look at the clouds that are there and they say, oh, Mr. Ashley, those clouds, that's the gas state? Not really. Clouds are actually very tiny droplets of water that are suspended in the atmosphere. And so they are in the liquid state, and the gas state of water is invisible. So our planet's real special in that you can find all three states of matter at one time existing on our planet Earth. And in our little tiny bit of the known universe, that's very special, because without water in all those different states, there would be no life on Earth. So we're going to be talking about how is it that water can go from one state to another, and why it does that, and how to predict what will happen when you change factors that affect state of matter. Okay, so let's take a quick look at a graphic here. You're going to see this graphic again, and I'm sorry my little face down there in the corner is covering up part of the graphic, but we can get some good information out of this, and it's basically a summary of some of the things that you're going to learn and some of the big ideas. So let's start all the way on the left. You can see that the first state of matter there on the left is a solid, and then as we move to the right, there's the liquid, and then finally all the way at the right, there's the gas state of matter. Now there's other things to notice about these states of matter. First of all, you can see that in a solid, the little blue spheres, which represent the water molecules, are packed together in a very orderly, very predictable pattern. Okay, and that's pretty much a characteristic of solids, is that they are very orderly. You could actually take a solid piece of water, an ice cube, and it would hold its own shape. You could set it on a table, it would still be an ice cube until it changed state into the liquid state. So let's move on over to the middle, and you can see that as a solid becomes a liquid, those water molecules, they're still touching each other, but they're kind of sliding across the surface of each other, and they are moving with more energy. Okay, so if you look back at the solid state, you're going to see that there's just a few little squiggles indicating that those water molecules are vibrating in position, maybe twisting, rotating, okay? But they're not really moving over each other like they would be if they were in the liquid state. And that's a big difference between a solid and a liquid. If you took water that was in a glass, liquid water, and you put it on the table and then poured out the glass, the liquid water would not stay in the shape of the glass that it was once in. It would spread over the surface of the table. So be thinking about what the molecules are doing. They're sliding over each other. They are not in a regular crystalline shape. Okay, so now let's head over to the right side, all the way on the right, and there is the gas phase. Now, at this point, those water molecules have so much energy, they're moving so much faster than they were in the liquid and solid phase, that they're actually not touching each other at all. And those water molecules are going to leave the container. Okay, they have so much energy they can actually spread out into the open space around them. We call that diffusion. So there you have it, solid, liquid, and gas. And it is the motion of these molecules and the amount of motion, we call it kinetic energy, that allows us to understand the behavior of the different states. So before we get into talking more about that, I want to point out one other thing. You can see that there's little arrows going both directions between each state of matter. For example, look at the between solid and liquid. The green arrow is pointing right, and then it's also pointing back to the left. And what we call these transitions are changes of state. So as solid water becomes liquid water, we call that liquefying or melting. And then let's go the other direction. As liquid water becomes solid water, obviously that's freezing, also known as solidifying. So there are some terms in here for the changes of state that you may be familiar with, but there's also some that you probably haven't heard before. So look at the top one where you go from a solid and you skip being a liquid and you go directly to being a gas. That's called sublimation. If you've ever played with dry ice, which is solid carbon dioxide, you know that it never makes your hands wet. You never see the liquid phase of carbon dioxide. That's because at our pressure on Earth, it doesn't exist as a liquid. So it can go just from a solid straight to being a gas. Those molecules fly apart really fast. And they don't have an arrow down on the bottom showing you, but you can also go from a gas directly to being a solid. You can go the reverse direction of sublimation. That one's called deposition. So more on these changes of state later. What I want you to see in this graphic are some of the characteristics of solids, liquids, and gases. And specifically, I want you to look at the amount of movement in each different phase. Okay? We use the amount of kinetic energy or movement in the phases to describe their behavior. And we use an explanation, also known as a theory, called the kinetic molecular theory. So let's take that word apart. Kinetic means to move, all right? Molecular means molecules, and theory means explanation. So the kinetic molecular theory explains the behavior and changes of state of matter based on the idea that all particles of matter are in motion. Okay? So what are the major ideas? Of course, molecules, atoms are always in motion. Okay? And what that means is if there's a lot of motion, what you're looking at is something that has a high temperature. Okay? High temperature. Now, what is temperature? We're going to have a whole chapter talking about temperature and energy and heat. Temperature is just a measure of the average kinetic energy in a substance. So if you have a high temperature, that means that the particles in that substance are moving fast. You can't see it with your eye, but they have a lot of motion, a lot of kinetic energy. So the converse is also true. If something is cold or has a low temperature, that means that the particles that make up that substance are not moving very fast. They're moving slowly, okay? Remember, temperature is just a measurement of average kinetic energy. Okay, one other thing we have to accept is that if these particles are moving and they hit each other, the collisions between them do not affect the energy of the particles. Now, in real life, those little collisions do absorb energy. But in order for us to describe the real world around us, we're just going to have to not worry about that amount of energy that is lost because it's so small compared to what we're seeing in the real world around us. Okay, now, the kinetic molecular theory, it's based on the idea that molecules are moving, and the faster they move, the higher their temperature, and the lower they move, the less they move, the lower their temperature. But is there a point at which you can find molecules that are not moving at all? And the answer to that question, according to the kinetic molecular theory, is yes. If you were to go backwards far enough, you'd eventually reach a point where the molecules aren't moving. So scientists were able to do that. They were able to extrapolate a graph backwards and determine at what temperature these molecules would not be moving at all. That has to be the lowest temperature possible. Okay? That temperature was found to be negative 273 degrees Celsius. So just to get it straight in your mind, water freezes solid at 0 degrees Celsius. Now go below that 273 steps and you are at the coldest possible temperature. That temperature is called absolute zero because there is no zero below it. It's the beginning of a whole new scale of temperature measurement that we use in chemistry called the Kelvin scale. That's going to come more into your life shortly, but you will be hearing about it for a few other chapters. And so that scale starts at absolute zero, where there is no more motion of molecules. Now, we've never been able to reach absolute zero. It's too difficult for us to get to be able to measure that, because anytime you introduce an instrument to measure that temperature, that instrument gives a little bit of energy to the molecules around it, so it's not at absolute zero. So just for your own knowledge, understand that absolute zero is the point at which there is no more motion of molecules. It is the lowest possible temperature. In Celsius, negative 273. In Kelvin, it is 0 Kelvin. Okay, so the amount of motion in a substance, okay, we call that the kinetic energy. If we were to measure that, that's the temperature of a substance, okay? So temperature is just the average kinetic energy of all the particles in a compound. That's what temperature is, okay? Heat is a different idea. Heat is actually the movement of energy. Temperature is the measurement of energy. And like I said, we're going to have a whole nother chapter just talking about that part of chemistry, but it's good to get just these basics today in this introduction to phases of matter, okay? All right, we're going to end today on this slide right here, which is just a very basic review of the 3 states of matter, okay? Ice, which is the solid state of water, vapor, which is the gas state of water, and then finally liquid water. That's the liquid state. And we'll be talking more about this and in depth, but you will be hearing again and again and again the following terms, so be comfortable with them: kinetic energy, temperature, state of matter, phase change. Okay? So we'll be discussing this again the next time we're together. Thanks for listening, guys, and take care.